Hello everyone and thank you for joining this session. My name is Jean Petit Bikim, master student at the University of Yaoundé I, supervised by Dr. Anzanzi Jumokon and co-supervised by Professor Dr. Sohen and Dr. Alad Oleyen in Germany. Today I'm excited to present the work done on leveraging GPT model for semantic table annotation. Generally, what is a tabular dataset? They are a set composed of tables used to structure and organize the data in the web, company, and so on. However, despite their importance, these tables are difficult to access, analyze, and utilize due to the missing data that we have in the table, ambiguous data, incomplete data, misspelled data, multilingual data, and irrelevant data. Nevertheless, we propose a solution that involves leveraging large language model with purpose to match tabular data to knowledge graph like Wikidata, Wikipedia, ORKD, and so on. In this regard, SemTab offers a challenge to evaluate and compare systems that can match tabular data to knowledge graph, to provide a benchmark dataset of tabular data and knowledge graph, as well as a set of evaluation metrics. At the end, to promote the development of the new techniques for matching tabular data to knowledge graph. Here, we have the dataset and the task we need to perform in accuracy crack and LLM crack. The first image presents the task to be performed by the dataset, and the second image presents the type of the table we had along with the task to be complete. This table presents an overview of the dataset used to perform the CEA tasks in accuracy and LLM crack. On the other hand, this table provides an overview of the dataset used for the CTA, CPA, FA, and TD tasks. We evaluate our system using three metrics to know: precision, recall, and F1 score. Then, this image presents the process that was implemented to fine-tune our model. First, we perform pre-processing on our input table by removing special character, too long space, and to correct the spelling of some words. Then we transform our table into vectors that we combine and compare with the structure of the target table in order to produce a new dataset in the form of table. After that, we transform each row of the table into a set of question-answer pair, which we then pass to the base model in order to obtain a fine-tuned model according to the task to be performed. This process involves four different modules to know. The first module is pre-processing, and here we have an image that gives us an example of how pre-processing is done. The second module is table to vect, and here we have also an image that presents the table to vect process for the CTA and CEA tags. The third module is table dataset, and here we have also an image that presents us the structure of the table that we obtain for the CTA, CEA, FA, and TD tags. For the last module, we have prompt generation, and here we have also an image that presents the different prompts that we use for the CEA, FA, TD, and CTA tags. As for the annotation process, it is almost similar to the fine-tuning process, with the only difference being that we use the fine-tuned model to perform the CEA, CTA, FA, and TD tags. However, the CPR task is done using rules based on Apple query to find the existing property between two columns. This image presents the scenario for the CPA task. First, we search for the entity, then we use the value contained in the other column to retrieve the correct entity. Once that is done, we associate the property ID whose value will help to identify the entity as a unified property for this column. Here we have these two tables that show the different results that we obtain in accuracy and LLM crack. The code is available on our GitHub repository, and the datasets are available on our Hugging Face collection. We thank TIB, LQS, and SemTab, and University of Yaoundé I to make it possible. Thank you.